The morning of June 17, 1944, Saipan, Mariana Islands. Colonel Takashi Goto stands in the open turret of his Type 97 Chiha medium tank, cavalry saber raised high above his head as dawn breaks across Tanapag Plain. Behind him, 43 tanks idle in attack formation, their engines rumbling like distant thunder through the volcanic soil. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Every Japanese tanker knows the numbers. The 9th Tank Regiment represents the finest armoured force the Imperial Japanese Army has committed to any Pacific island. Their Type 97 Chihas carry 47mm guns, capable of penetrating 25mm of armour at 500 metres. Against the lightly armoured American tanks encountered in China and Malaya, these specifications proved more than adequate. When the salvage team finally examines a disabled American tank 3 days later, what they discover will shatter 6 months of strategic assumptions and expose a technological gap so vast that it would fundamentally alter Japanese defensive doctrine for the remainder of the war. The American Sherman sitting motionless near Charan Kanoa airfield appears almost undamaged from a distance. The tank measures over 18 feet in length and stands nearly 10 feet tall. Its weight exceeds 30 tons, twice that of the Type 97. But what catches the attention of Lieutenant Hiroshi Nakamura, assigned to assess captured enemy equipment, is the armour itself. Nakamura runs his hand along the Sherman's glacis plate. The metal feels solid and thick under his palm, fundamentally different from Japanese tank construction. He pulls out his measuring tools and begins systematic documentation. The front hull armour reads 76mm at a 56-degree angle. Thickness approaches 93mm when accounting for slope. This cannot be their standard specification. No medium tank carries this much protection, Nakamura mutters to his assistant. At Imperial Japanese Army Technical Headquarters in Tokyo, engineers had estimated American medium tank armour at perhaps 50mm maximum. The Type 97's 47mm gun was designed to defeat such protection at combat ranges. Nakamura climbs onto the Sherman's hull and peers through the driver's vision port. Steel armour plating backs the crew positions. Bulletproof glass protects forward-facing viewports. Even the ammunition storage shows protective measures, housed in liquid-filled compartments designed to prevent fires. The gun mantlet alone measures 76mm of solid steel. The turret sides, which should represent the weakest protection, still exceed 51mm. The Sherman's designers had built a tank intended to absorb punishment and keep fighting. Japanese engineers had built tanks optimized for mobility and offensive power, expecting that superior training and tactical skill would compensate for lighter armor. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The mathematics were brutal and undeniable. The Type 97's 47mm gun, firing standard armor-piercing rounds, could penetrate approximately 55mm of vertical armour at 100 metres. Against the Sherman's sloped frontal armour with its effective thickness of 93mm, the Japanese tank gun was completely ineffective at any range except point-blank side shots. The Sherman's 75mm gun told an even more devastating story. Nakamura examines the massive breech mechanism and the armour-piercing rounds still stored in their protective racks. Each shell weighs nearly 7 kilograms and travels at 620 meters per second. The penetration tables captured from American technical documents reveal capabilities that make Nakamura's hands tremble slightly as he records the numbers. At 500 meters, the Sherman's 75mm gun penetrates 81mm of armor at 0 degrees from vertical. At 1,000 meters, still 73mm. The Type 97's maximum armor thickness of 25mm on the gun mantlet and just 15mm on the hull front meant that American tankers could destroy Japanese armor at ranges exceed 1,800 meters. The engagement envelope disparity was catastrophic. Japanese tanks needed to close to within 200 meters for any chance of penetration against Sherman frontal armor. American tanks could engage and destroy Japanese armor from almost 2,000 meters with near certainty. The Sherman enjoyed a 9-to-1 range advantage in effective combat distance. Lieutenant Nakamura's report to Tokyo arrived by encrypted transmission on June 20th. The technical specifications he documented would force a complete re-evaluation of Japanese armor doctrine, but the real story had already been written 3 nights earlier on Tanapag Plain, when Colonel Goto led his regiment into battle. The attack began at 0300 hours on June 17th. Goto's 43 tanks rolled forward through pre-dawn darkness, supported by elements of the 136th Infantry Regiment. Japanese doctrine called for rapid shock attacks before enemy forces could establish defensive positions. The Marines had landed just 36 hours earlier. This was Japan's best opportunity to drive the invaders back into the sea. Private First Class Robert O'Malley of the 2nd Battalion, 6th Marines, heard the tanks before he saw them. The rumble of diesel engines carried across the open ground between Japanese positions and the Time 7 American beachhead. The sound grew louder, closer, unmistakable. "Tanks!" O'Malley shouted to his squad. "Incoming armor from the north!" The Marines scrambled for defensive positions. Forward observers radioed requests for naval illumination rounds. Within minutes, star shells from offshore destroyers turned night into artificial day across Tanapag Plain. The brilliant magnesium light revealed a sight that would have been terrifying under different circumstances. Dozens of Japanese tanks advanced in loose formation across open ground. Infantry troops rode on the tank hulls or ran alongside the vehicles. Battle flags streamed from antenna mounts. The attack embodied traditional Japanese offensive spirit, courage and aggression, driving forward without regard for casualties. But courage could not overcome physics. The Marines were not the poorly equipped Chinese forces that Japanese tanks had dominated in Manchuria. They were not the surprised British defenders of Malaya facing an unexpected jungle assault. These were United States Marines with armor-piercing bazookas, towed 37mm anti-tank guns, and most critically, M4A2 Sherman tanks from the 2nd Marine Tank Battalion. Sergeant William Chamberlain commanded one of 3 Sherman tanks positioned near the 6th Marines' defensive perimeter. When the star shells illuminated the advancing Japanese armor, Chamberlain had perfect visibility across 1,200 meters of flat terrain. "Multiple targets," Chamberlain reported to his gunner. "Type 97s in the open. Range 1100. Engage at will." The Sherman's 75mm gun had been designed for exactly this scenario. The gyroscopic stabilizer, though often disconnected by crews due to its complexity, allowed reasonably accurate fire while moving. But Chamberlain's tank was stationary in a prepared firing position with clear sight lines. His gunner had all the advantages. The first Sherman round struck a Type 97 at the base of its turret. The armor-piercing projectile penetrated completely through the 15mm hull armor, detonated the explosive filler inside the shell, and turned the tank's interior into a killing zone. The Japanese tank erupted in flames as stored ammunition cooked off. The second shot hit another Type 97 through its frontal armor, punching through the thin steel as if it were paper. The third shot disabled a third tank by destroying its track and suspension. Within 90 seconds, Chamberlain's single Sherman had eliminated 3 Japanese tanks at a range where Japanese guns could not even scratch American armor. Across the battlefield, similar engagements played out with mathematical inevitability. Marine infantry fired M1A1 bazookas at Japanese tanks that penetrated too close to defensive lines. The 2.36-inch rocket projectiles, though short-ranged, could defeat the Type 97's thin armor when striking perpendicular surfaces. Towed 37mm anti-tank guns engaged targets at medium range, their armor-piercing rounds effective against Japanese armor out to 800 meters. But it was the Sherman tanks that proved truly devastating. The 3 M4A2s from 2nd Marine Tank Battalion, supported by several M3 75mm self-propelled guns, created an impenetrable wall of firepower. Every Japanese tank that entered their engagement envelope died within seconds. Colonel Goto, standing in his command tank's turret with his cavalry sabre still raised, saw his regiment disintegrate before his eyes. Tanks exploded into fireballs. Crews bailed out of disabled vehicles only to be cut down by machine gun fire. Infantry troops running alongside the armor fell in windrows under the devastating volume of American defensive fire. The Type 97 tanks that reached Marine lines discovered another horrifying reality. Even at point-blank range, their 47mm guns struggled to penetrate Sherman armor. Lieutenant Kenji Yamamoto, commanding one of the few Japanese tanks to survive the initial exchange, fired 3 rounds at a Sherman from less than 50 meters. The first round struck the frontal glacis and ricocheted skyward. The second round hit the turret face and shattered without penetrating. The third round never fired because a Marine bazooka team destroyed Yamamoto's tank with a rocket through the engine compartment. The battle lasted less than 2 hours. As dawn broke fully across Saipan, the tactical assessment was clear and brutal. Of the 43 Japanese tanks that began the attack, 31 were destroyed outright. Most of the remaining 12 were disabled by track damage or mechanical failure. Japanese infantry casualties exceeded 400 men. The 9th Tank Regiment, the finest armoured unit the Imperial Japanese Army had committed to the Pacific Islands, had been effectively annihilated. American losses told the opposite story. The 3 Sherman tanks emerged undamaged. A handful of Marines were killed or wounded, primarily from Japanese infantry weapons rather than tank fire. The disparity in casualties reflected the fundamental mismatch in equipment capability. The Sherman that Lieutenant Nakamura examined 3 days later wore the scars of the battle. Multiple impact marks dotted its hull and turret, where Japanese 47mm rounds had struck without penetrating. Nakamura used a metal probe to examine the impact craters. The deepest penetration measured just 11mm into the Sherman's armor, less than 15% of the steel thickness. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The Japanese shells had been striking armor nearly twice as thick as they could penetrate. It was equivalent to firing a rifle at a concrete bunker and expecting penetration. But the true revelation came when Nakamura examined the Sherman's gun and its ammunition storage. The American tank carried 90 rounds of 75mm ammunition, divided between armor-piercing and high-explosive types. The armor-piercing rounds used a design called APCBC, armor-piercing capped ballistic cap. The soft metal cap prevented shell shatter against face-hardened armor. The aerodynamic ballistic cap maintained velocity at range. A small explosive charge in the shell base detonated after penetration, fragmenting the projectile inside the target. It was elegant engineering optimized for exactly the kind of tank versus tank combat that the Sherman had just demonstrated. Japanese armor-piercing ammunition used simpler solid-shot designs with inferior ballistic performance and no post-penetration effects. Nakamura spent 2 days measuring, photographing, and documenting every aspect of the captured Sherman. His report filled 43 pages with technical specifications, armor measurements, ammunition analysis, and tactical assessments. The conclusion was inescapable and devastating. The Imperial Japanese Army's medium tanks were obsolete, not merely inferior, but fundamentally incapable of engaging American armor in anything resembling equal combat. The Type 97 Chaiha had been designed to fight Chinese resistance forces and lightly armored British colonial troops. It had never been engineered to face the industrial might of American tank production. The weight differential alone told much of the story. The Type 97 weighed 15 tons fully loaded. The Sherman weighed 33 tons. That 18-ton difference translated directly into armor protection, gun size, ammunition capacity, and crew survivability features. American tankers operated from inside what was essentially a mobile fortress. Japanese tankers drove targets. The armor comparison revealed design philosophies that could not have been more different. American engineers had prioritized crew survivability alongside offensive capability. The Sherman featured armor backing for crew positions, armored glass for vision ports, self-sealing fuel tanks that prevented catastrophic fires, and ammunition storage designed to minimize cook-off explosions. Every design element reflected a doctrine that valued trained crews as irreplaceable assets. Japanese tank design reflected opposite priorities. The Type 97 sacrificed protection for mobility and cost-effectiveness. Armor thickness was minimized to reduce weight and improve speed. No armor backing protected crew positions. Fuel tanks used standard steel construction without fire suppression systems. Ammunition was stored wherever space permitted without protective measures. This design philosophy made perfect sense when Japanese armor faced Chinese forces equipped with limited anti-tank weapons, or when supporting infantry attacks against defensive positions. The Type 97 excelled at infantry support missions, where its mobility and reliability mattered more than armor protection. But against American combined arms tactics, the design philosophy became a death sentence. Every engagement with Sherman tanks demonstrated the same pattern. Japanese armor had to close to suicidal ranges for any chance of penetration. American armor could engage and destroy Japanese tanks from comfortable distances while remaining invulnerable to return fire. The industrial capacity disparity made the situation even more hopeless. By June 1944, American factories had produced over 30,000 Sherman tanks. The massive industrial base could replace losses faster than combat could destroy vehicles. Japanese industry, already straining under resource shortages and strategic bombing, had produced fewer than 3,000 Type 97 tanks total since production began in 1938. Lieutenant Nakamura's report reached Tokyo on June 22nd. The technical intelligence staff read his findings with growing alarm. The armor measurements, penetration calculations, and combat assessments painted a picture of technological inferiority that contradicted years of confident assumptions about Japanese military capability. Major General Tomoyuki Yamashita, responsible for armored forces development, convened an emergency meeting of tank designers and ordnance specialists. The question was simple and urgent. How quickly could Japanese industry produce tanks capable of engaging Sherman armor on equal terms? The answer was devastating. Japan had already developed the Type 3 Chi-Nu and Type 4 Chi-To medium tanks, both armed with 75mm guns comparable to the Sherman's armament. But these advanced designs existed primarily as prototypes. Industrial capacity, raw material shortages, and competing priorities for aircraft and naval production meant that fewer than 200 improved tanks could be produced before war's end. The Type 3 Chi-Nu featured a high-velocity 75mm gun mounted in a redesigned turret. Its armor protection reached 50mm on frontal surfaces, still inferior to Sherman protection, but at least adequate to require American gunners to aim carefully. The gun could penetrate Sherman armor from frontal aspects at ranges under 500 meters. But producing the Type 3 Chi-Nu required manufacturing capacity that Japan no longer possessed. Steel allocation prioritized aircraft production for homeland defense. Machine tool availability limited the number of tanks that could be built simultaneously. Skilled labor was increasingly scarce as workers were conscripted for military service or diverted to emergency war production. Only 166 Type 3 Chi-Nu tanks were completed by August 1945. The Type 4 Chi-To, an even more advanced design with better armor and a more powerful gun, achieved the production of just 2 prototypes before the war ended. Japanese industry simply could not match American tank production in either quantity or technological advancement. The strategic implications were clear to anyone willing to face reality. Japanese armored forces could not stop American advances through conventional tank warfare. The Battle of Saipan had proven that decisive engagement between armor forces would result in Japanese annihilation, regardless of tactical skill or crew courage. General Yamashita proposed a fundamental change in armor doctrine. If Japanese tanks could not engage American armor successfully, they should not attempt to do so. Instead, tanks would be used as mobile pillboxes, dug into defensive positions where only their turrets remained exposed. The armor would serve as direct fire support for infantry, engaging American forces from concealed positions rather than maneuvering for tank versus tank combat. This defensive doctrine represented a complete abandonment of mobile armored warfare. The Type 97 Chiha had been designed for offensive operations, supporting rapid infantry advances through superior mobility. Now these same tanks would be buried in the ground, their mobility advantage sacrificed because their armor and guns were inadequate for the war Japan was actually fighting. The doctrine was first implemented at Iwo Jima in February 1945. Japanese defenders dug tank positions into the volcanic rock, creating firing points that exposed only the turret and gun. Type 97 tanks became essentially immobile fortifications, waiting for American forces to come within their limited engagement range. The tactic achieved marginal success. American forces could not simply drive Sherman tanks across open ground and expect to survive concentrated anti-tank fire from concealed positions. But the fundamental problem remained. Once located, Japanese tank positions were destroyed by American artillery, naval, gunfire, tank destroyers, or close assault teams with demolition charges. At Okinawa in April 1945, Japanese forces fielded their most effective anti-tank weapon yet developed. The Type 147mm anti-tank gun used the same 47mm barrel as the improved Type 97 Shinhoto Chiha tank, but mounted on a lightweight towed carriage that could be rapidly repositioned. The Type 147mm gun represented Japanese ordnance design at its best. The weapon featured a high muzzle velocity of 823 meters per second. It could penetrate 70 millimeters of armor at 500 meters, sufficient to defeat Sherman side armor at range or frontal armor at close distance. American intelligence reports called it an excellent weapon with mechanized carriage and high effectiveness. But production numbers told the familiar story. Only 2,300 Type 1 guns were manufactured during the entire war. For comparison, American factories produced over 60,000 75mm tank guns for Sherman installation alone, not counting the thousands of towed anti-tank guns, tank destroyers, and self-propelled artillery pieces. Japanese anti-tank doctrine at Okinawa called for Type 1 guns to hold fire until American armor closed to within 200 meters, then engage side and rear aspects where Sherman armor was most vulnerable. The tactic worked when conditions permitted. American tank losses at Okinawa exceeded previous Pacific campaigns, but the doctrine also revealed the desperation underlying Japanese defensive planning. Waiting until enemy tanks closed to 200 meters meant accepting that American forces would penetrate defensive lines. It meant Japanese anti-tank gunners would be operating under direct fire from American infantry, artillery, and supporting armor. It meant accepting casualties that could not be replaced. The Battle of Saipan had exposed a truth that Japanese military leadership spent the next 14 months trying to overcome through tactical innovation and desperate fighting. The technological gap between Japanese and American armored forces was not a problem that could be solved through better training or superior spirit. It was an industrial and engineering reality that reflected the fundamental disparity in national productive capacity. Sherman tanks could be produced by the thousands because American industry possessed the steel mills, machine tools, trained workers, and electrical power to manufacture complex mechanical systems at scale. Japanese industry, blockaded by American submarines and bombed by American aircraft, could barely maintain production of existing weapons, let alone develop and manufacture improved designs. The fuel situation made matters worse. The Type 97 Chiha used a diesel engine that provided good fuel efficiency and reduced fire risk compared to gasoline engines. By 1945, Japan's fuel supplies were so constrained that even diesel fuel became difficult to obtain. Tanks sat immobile in defensive positions not because of tactical doctrine but because there was no fuel to move them. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. American tankers, by contrast, operated in an environment of material abundance that Japanese forces could scarcely imagine. Sherman tanks consumed fuel at approximately 1 gallon per mile during road travel. The logistics train supporting American armored operations delivered not just fuel, but spare parts, ammunition, replacement vehicles, and complete maintenance facilities. When a Sherman tank was disabled by enemy fire, American recovery vehicles would retrieve it from the battlefield. Repair depots would assess damage and either fix the vehicle or cannibalize it for spare parts. The industrial system treated tanks as repairable assets rather than expendable equipment. Japanese forces had no comparable logistics infrastructure. The experience of Corporal James Mitchell, a Sherman tank commander with the 4th Marine Division, illustrated the operational reality. His tank, named Fury, took a hit from a Japanese 47mm anti-tank gun during fighting on Saipan. The round penetrated the sponson armor on the right side, wounding the assistant driver and damaging internal components. Mitchell drove the tank back to the beach maintenance area, where a mobile repair crew assessed the damage. Within 36 hours, Fury had been repaired with replacement parts shipped from Hawaii. The tank returned to combat with its original crew minus the wounded assistant driver, who was replaced immediately. Japanese tank crews disabled in combat faced completely different circumstances. If the tank could not be immediately repaired with available materials, it was abandoned. No, recovery vehicles existed to retrieve disabled armor from forward positions. No spare parts were available to replace damaged components. Crews from destroyed tanks were reassigned to infantry units because there were no replacement tanks. The mathematics of attrition warfare favored the side that could replace losses faster than they occurred. American armored forces grew stronger throughout the Pacific Campaign, as more Sherman tanks, better ammunition, and improved support equipment arrived from stateside production. Japanese armored forces grew weaker as irreplaceable losses accumulated and industrial capacity declined. By the summer of 1945, as American forces prepared for the invasion of Japan's home islands, the disparity had reached almost absurd proportions. American planning called for deploying thousands of Sherman tanks supported by improved tank destroyers, self-propelled artillery, and amphibious armor. Japanese defensive planning relied primarily on suicide tactics using pole charges, magnetic mines, and human wave attacks. The Type 97 Chiha tanks that survived to this point were essentially useless as mobile armor. Most were buried in static defensive positions or hidden in caves, their role reduced to immobile gun platforms that would fire a few rounds before being destroyed. The tanks designed for offensive mobile warfare had been rendered obsolete by an enemy whose industrial capacity could outproduce Japanese manufacturing by factors of 10 to 20 in every category. Lieutenant Nakamura's report from Saipan in June 1944 had documented this reality with painful precision. The captured Sherman represented not just superior engineering, but an entirely different level of industrial capability. Every measurement, every specification, every design element reflected a nation that could afford to build 33-ton tanks with multiple layers of protection, powerful guns, and crew comfort features. Japanese tank designers had made rational choices based on available resources and expected opposition. They had created vehicles optimized for infantry support operations against lightly equipped opponents. These designs performed well in China and early Pacific operations. But the arrival of Sherman tanks in combat changed the equation completely. American armor represented an opponent that Japanese tanks simply could not engage on equal terms. The range advantage, armor advantage, and numerical advantage combined to make tank versus tank combat suicidal for Japanese crews. The captured Sherman that Nakamura examined remained on Saipan throughout the battle. American forces secured the island by July 9, 1944. Recovery crews eventually retrieved the tank, repaired it, and returned it to service. That single Sherman probably outlasted the entire Japanese 9th Tank Regiment that attacked on June 17. The Battle of Saipan represented the largest tank engagement of the Pacific War. It was also the last time Japanese forces attempted a major armored attack against American positions. Every subsequent defensive operation relied on static defense, suicide tactics, and attempts to negate American armor advantages through terrain selection and concealment. The Type 97 Chiha continued serving through war's end, not because it was effective, but because no alternative existed. The few hundred improved tanks produced were insufficient to equip more than a handful of units. Most Japanese armored forces fought with equipment they knew was obsolete, facing enemies they knew they could not defeat through conventional combat. The final irony of Japanese tank development emerged in the war's closing months. Engineers at Mitsubishi Heavy Industries completed design work on the Type 5 Chai-Ri medium tank in early 1945. The vehicle represented Japan's most ambitious armor project, featuring a 75mm main, gun comparable to the Sherman's armament, frontal armor approaching 75mm, and a weight of 37 tons. The Type 5 Chai-Ri was designed specifically to counter Sherman tanks on roughly equal terms. Its gun could penetrate Sherman armor at combat ranges. Its armor could resist 75mm fire at moderate distances. The tank embodied everything Japanese engineers had learned from 3 years of losing armored engagements against American forces. Only one prototype was completed before Japan's surrender. The industrial capacity required to manufacture such a complex vehicle simply did not exist by 1945. American strategic bombing had destroyed much of Japan's heavy industry. Submarine blockade had cut off raw material supplies. Electrical power shortages limited manufacturing operations. The ability to design an effective tank meant nothing without the industrial base to produce it in meaningful numbers. The contrast with American production was staggering. While Japanese engineers struggled to complete a single prototype of their most advanced tank, American factories were producing improved Sherman variants at rates exceeding 1,500 per month. The M4A3E8 Sherman, featuring improved suspension, better armor, and a high-velocity 76mm gun, entered service in late 1944. Thousands rolled off production lines in the first half of 1945. American tank development had not stood still while Japanese forces struggled with obsolete equipment. The M26 Pershing heavy tank entered service in February 1945, featuring a 90mm gun and armor protection that made it virtually immune to any Japanese anti-tank weapon. Though only 20 Pershings reached combat before war's end, their arrival demonstrated that American industry could not only produce existing designs at scale, but also develop and field entirely new vehicles simultaneously. The industrial disparity extended beyond mere production numbers. American tanks featured components manufactured to precise tolerances with interchangeable parts across production batches. A Sherman tank damaged in combat could be repaired using parts from any other Sherman, regardless of which factory had produced the original vehicle. Japanese tanks lacked such standardization. Parts from one manufacturer's Type 97 often would not fit another manufacturer's version of the same tank. Quality control represented another fundamental difference. American production lines employed systematic inspection procedures and statistical process control to ensure consistent quality. Japanese production, especially late in the war, suffered from declining quality, as experienced workers were conscripted and manufacturing rushed to meet emergency quotas. Tanks rolled off production lines with defects that would have been caught and corrected in American factories. The logistics infrastructure supporting armor operations reflected the same disparity. American forces deployed specialized recovery vehicles, mobile maintenance units, forward repair depots, and comprehensive spare parts distribution networks. A Sherman tank disabled in combat had better than 70% chance of being recovered, repaired, and returned to service. Japanese forces had no comparable logistics system. A Type 97 disabled beyond immediate field repair was simply abandoned. The crew salvaged personal equipment and whatever weapons or ammunition could be carried. The tank itself became scrap metal. Japanese industry could not produce replacement tanks at rates sufficient to offset combat losses, so every tank destroyed was essentially permanent loss. The human cost of this technological mismatch was immense and tragic. Japanese tank crews were trained soldiers who understood their equipment's limitations. They knew that engaging Sherman tanks meant almost certain death. Yet military, discipline and cultural expectations demanded that they fight anyway. Sergeant Takeshi Kobayashi, a tank commander with the 9th Tank Regiment, survived the Saipan attack by mechanical luck. His Type 97's engine failed during the advance, leaving him stranded 300 meters behind the main assault. He watched through binoculars as American fire systematically destroyed his regiment. Years after the war, Kobayashi described the experience in an interview. "We knew our tanks were inferior. Every crew member understood that Sherman armor was too thick for our guns except at suicide range. But orders were to attack, so we attacked. I lost my entire company that night, 23 men dead because our tanks were not good enough to fight the enemy we faced." The Battle of Saipan killed over 3,000 Japanese soldiers in the failed counterattacks on June 17th and the subsequent fighting. The 9th Tank Regiment's armoured assault accounted for more than 400 casualties directly, with most deaths occurring in the first 90 minutes of combat. American casualties in the same engagement totaled fewer than 100 killed and wounded. These numbers told the story that Japanese military leadership struggled to acknowledge. Superior training and fighting spirit could not compensate for fundamental equipment inadequacy. Courage could not overcome the mathematics of armor penetration and engagement range. Japanese tank crews were dying not because they fought poorly, but because they were driving tanks that could not compete with American armor. The defensive doctrine adopted after Saipan represented an implicit admission of this reality. By digging tanks into static positions, Japanese commanders acknowledged that mobile armor warfare against American forces was suicide. The tanks designed for offensive operations would spend their final battles as immobile pillboxes, because any attempt at maneuver would result in immediate destruction. Even this defensive use proved largely ineffective. American forces developed systematic methods for reducing Japanese strongpoints. Artillery and naval gunfire would saturate suspected tank positions. Infantry would call in close air support to attack with bombs and rockets. Tank destroyers mounting 90mm guns could engage Japanese positions from ranges where return fire was ineffective. Flamethrower tanks could assault bunkers and buried armor with weapons against which there was no defense. At Iwo Jima in February 1945, Japanese forces employed every defensive tactic developed through bitter experience. Tanks were buried with only turrets exposed. Anti-tank guns were positioned in interlocking fields of fire. Suicide squads trained to attack American armor with pole charges and magnetic mines. The entire island had been turned into a fortress designed to inflict maximum casualties on American attackers. American forces still secured the island in 36 days. Japanese tank positions were systematically identified and destroyed. The buried Type 97 tanks provided temporary obstacles that delayed American advances by hours rather than days. Once located, they were eliminated by concentrated firepower from weapons against which they had no effective response. The final accounting was grimmer still. Of approximately 23,000 Japanese defenders on Iwo Jima, fewer than 300 survived to surrender. American casualties exceeded 26,000 killed and wounded, making it one of the bloodiest battles of the Pacific War. But the casualty ratio, while terrible by American standards, still heavily favored the attackers. For every American killed, more than 3 Japanese defenders died. These numbers would have been unthinkable in early Pacific fighting when Japanese forces held significant tactical and sometimes technical advantages. The shift reflected the cumulative effect of American industrial supremacy. Better equipment, unlimited ammunition, overwhelming firepower, and the ability to replace losses made American victory inevitable despite determined Japanese resistance. The Type 97 Chiha that Lieutenant Nakamura examined on Saipan in June 1944 represented a machine built for a different war. Japanese designers in the late 1930s had created a tank optimized to fight Chinese resistance forces and lightly equipped colonial armies. The specifications made perfect sense for those opponents and for the limited industrial capacity available to Japanese manufacturers. But the war Japan actually fought required tanks capable of engaging American armor on equal terms. That requirement demanded heavier armor, more powerful guns, better crew protection, and sophisticated fire control systems. Meeting those requirements would have required industrial capacity that Japan simply did not possess. American industry could produce 33-ton Sherman tanks by the thousands because the United States had the steel mills, factories, machine tools, electrical power, trained workforce, and logistics infrastructure to support such production. Japan lacked these fundamental industrial prerequisites. No amount of tactical innovation or fighting spirit could substitute for industrial capacity, measured in millions of tons of steel and thousands of machine tools. The captured Sherman represented this disparity in physical form. Every aspect of its design, from the thick armor to the powerful gun to the crew comfort features, reflected a nation that could afford to build tanks optimized for crew survival and combat effectiveness without worrying about weight or cost. Japanese designers made the best possible use of limited resources. American designers worked within an industrial framework that made such limitations largely irrelevant. Lieutenant Nakamura understood this when he filed his report. The technical specifications documented a machine that Japanese industry could not duplicate and could barely comprehend. The 43 pages of measurements and analysis ultimately described an industrial capability gap rather than merely a technical one. Japan was not losing the armor war because of poor design decisions. Japan was losing because American factories could build better tanks faster than Japanese factories could build inferior ones. The final irony of Japanese tank development emerged in the war's closing months. Engineers at Mitsubishi Heavy Industries completed design work on the Type 5 Chiri medium tank in early 1945. The vehicle represented Japan's most ambitious armor project, featuring a 75mm main gun comparable to the Sherman's armament, frontal armor approaching 75mm, and a weight of 37 tons. The Type 5 Chiri was designed specifically to counter Sherman tanks on roughly equal terms. Its gun could penetrate Sherman armor at combat ranges. Its armor could resist 75mm fire at moderate distances. The tank embodied everything Japanese engineers had learned from 3 years of losing armored engagements against American forces. Only one prototype was completed before Japan's surrender. The industrial capacity required to manufacture such a complex vehicle simply did not exist by 1945. American strategic bombing had destroyed much of Japan's heavy industry. Submarine blockade had cut off raw material supplies. Electrical power shortages limited manufacturing operations. The ability to design an effective tank meant nothing without the industrial base to produce it in meaningful numbers. The contrast with American production was staggering. While Japanese engineers struggled to complete a single prototype of their most advanced tank, American factories were producing improved Sherman variants at rates exceeding 1,500 per month. The M4A3E8 Sherman, featuring improved suspension, better armor, and a high-velocity 76mm gun, entered service in late 1944. Thousands rolled off production lines in the first half of 1945. American tank development had not stood still while Japanese forces struggled with obsolete equipment. The M26 Pershing heavy tank entered service in February 1945, featuring a 90mm gun and armor protection that made it virtually immune to any Japanese anti-tank weapon. Though only 20 Pershings reached combat before war's end, their arrival demonstrated that American industry could not only produce existing designs at scale, but also develop and field entirely new vehicles simultaneously. The industrial disparity extended beyond mere production numbers. American tanks featured components manufactured to precise tolerances with interchangeable parts across production batches. A Sherman tank damaged in combat could be repaired using parts from any other Sherman, regardless of which factory had produced the original vehicle. Japanese tanks lacked such standardization. Parts from one manufacturer's Type 97 often would not fit another manufacturer's version of the same tank. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.